Hello everyone, welcome to this tutoring video. So today we are going to do some math, more specifically stuff to do with matrices, which is something that we do in Algebra 2. And sorry, the camera is a bit out of focus there. Should settle in over time, but anyways, quick disclaimer. There were actually people who were supposed to come to be or like that I was supposed to teach, but they didn't show up. So I'm just going to do this without people, and people who view this video can watch and enjoy. There we go. So, now is when the actual video should be starting. But, okay. So, I'm going to walk you through 4 problems, each about matrices, and then we are going to see how you do with them, and let me know in the comments if this was helpful. Yeah. Okay, so the first one is just basic adding of matrices. So, well, first of all, let me first write out what is a matrix. Or it's actually in singular form. It's called matrix, or matrix. In plural, it's matrices. So a matrix is kind of like, I don't really know how to define it, but I'm going to draw out what it basically is. So say you have, it's something like this. By the way, this is just for those of y'all who don't know what matrices are. So I don't know. X, Y, Z, A. That would be an example of a matrix. But this would be a 2 by 2 matrix. Okay, 2 by 2 matrix. And the thing is that there are a matrix is just basically a many series of numbers within a bracket. And here's the weird part. If you have, say, a 3, well, first of all, there's this pattern. It's called rows by columns. You might not understand what I'm talking about now, but it will be important in just a second. So there is actually a difference between, say, if you had a 2 by 3 matrix and a 3 by 2. So a 2 by 3 would be, because it's rows by columns, that would be 2 rows and 3 columns. A 3 by 2 would be 3 rows and 2 columns. Therefore, they are different in how they look. So a 2 by 3 would be something like, see, 2 rows, 3 columns, so it would be A, B, C, D, E, F, okay? But a 3 by 2 would be different because there would only be 2 columns but 3 rows. So that'd be like A, B, C, D, E, F, okay? So if you all understand this concept, then we are ready to move on to our very first problem. So, it take me a second here to wipe down the board. These whiteboards. Yeah, much more efficient and if I didn't do this with my hands. Now I'm going to have to wash it after this video. So now we are just going to do basic adding of matrices. First, I'm going to go ahead and give an example. So, an example would be, let's say we do a 3 by 3 matrix plus another 3 by 3 matrix. We would say 5. Okay, I'm just going to write down random numbers. So 3 by 3. Yeah. So let's say that this is an 8, 4, 5. Okay, and then if we add this with a, I need to write these smaller. If we add this with another one, yeah, kind of hard to. Dang it. That's a 3. You might not be able to see it very well, but that's a 5, 2, 3. Okay. Let me bring this closer. So what we would do is we take each number, like see 5, 7, the same corner, we would add them, so then this would be 12. 9, 10, 19. 11 plus 5, that would be 16. 10 plus 4, 14. 2 plus 6 is 8. 6 plus 2, also 8. 8 plus 8, 16. 1 plus 4, 5. 5 plus 3, 8. So our answer for 3 by 3 matrices adding, we would get 5 plus 7, 12, or okay, 5, 9, 11, 2, 10, 2, 6, 8, 4, 5 matrix plus 7, 10, 5, 4, 6, 2, 8, 1, 3 is 12, 19, 16, 14, 8, 8, 16, 5, 8. Alright? So now, I hate that this thing is always like getting out of focus. Alright. Now we are going to actually work a problem. Yeah. Now I'm going to use, that was an example, and now I'm going to give you something like that, and now you guys have to solve it yourselves. Okay. What am I? Okay. So now, we are going to do just like that. And this time, let's do it. Let's add two 4x4 matrices, because you guys understand the concept, I hope. If not, you should probably pause the video and go back a few seconds or minutes or whatever. But we're going to add two 4x4s, which will result in a 4x4. Oh, by the way, you can only add two matrices if they are the exact same, or else it is undefined. And often on a math quiz or test, a lot of teachers will want you to say this is undefined and explain why, because this is a 2x2, this is a 3x2, 4x4, 5x4, this. So yeah, just know that most math teachers, especially if you're in advanced pre-AP or whatever, they will most likely expect for you to do that. Okay, so I'm going to take 4x4. Alright, so 8, 1, 5, 7, 12, 7, 8, 7, 6, 2, 1, 2, 5, 13, -5, 8. Okay, let's add that to, let me drop this bigger. You guys may find it hard to read it. But yeah, we have 8, 1, 5, 7, 12, 7, 8, 7. This is a 6. So I can write on a tiny whiteboard with limited space. 2, 1, 2, 5, 13, -5, 8. Yeah, you may have a hard time telling that this is an 8 right here. Okay, alright. So, and then let's add that to -5, 2, 0, 1, 4, 2, -6, 1, 22, 3, 5, 8, 9, -14, 13, 0, 5, 3, -1, 7. Do this matrix a little big. Yeah. Okay. Alright, now pause the video and go ahead and just try to solve this. So just pause the video right about here and look at this and just try to solve it. Okay, so you should have got, because remember we are adding this, and I should have wrote a plus sign equals. Okay, if you want to solve it, because now that you can actually read that you're adding them, I told you about it, so if you're paying attention you should know, but if you just want a second, I will give that to you right now. Okay, so The answer is 3, 3, 5, 8. Second row, 16, 9, 2, 8. Third row, hold on, there seems to be a mistake in. Oh, okay. Okay. So sorry about that. This is 24. Not 16, this is 24. This is 3, 3, 5, 8. Oh, yeah, it is 16. I misread my own matrix there. So sorry about that. 9, 2, 8, and then going down to the next row, 28, see, well, first of all, ignore these at the bottom here. I wrote some extra. I don't know why I did that, but I wrote a few extra. I made this a 4x5, so go ahead and cross it out. Yeah, sorry you messed that up. I'm going to give you a few more seconds to try to solve it. Go ahead, pause the video if you still have not been able to solve it. See if you can do it. Okay. Okay, and actually, you may have actually just solved part of it because I already gave you some of the answers. But in general, I mean, you should have just been able to pretty much tell that that was a mistake. I'm so sorry about that, guys. Yeah. Okay. Anyways, 2 plus 3 here, we get 5. 1 plus 5. 6, 2 plus 8, or no, yeah, 2 plus 8, 10. 5 plus 9, 14. 13 plus negative 14, negative 1. Negative 5 is 13, 8. Eight plus 0, 8. So yeah, your answer for the matrix, matrices, it's plural, 8, 1, 5, 7, 12, 7, 8, 7, 6, 2, 1, 2, 5, 13, negative 5, 8 plus negative 5, 2, 0, 1, 4, 2, negative 6, 1, 2, 3, 5, 8, 9, negative 14, 13, 0. Should leave you at 3, 3, 5, 8, 16, 9, 2, 8, 28, 5, 6, 10, 14, negative 1, 8, 8. If you didn't get that, I recommend going through your work and figuring out why. But, I mean, that's the answer. But, yeah. So for the next problem, I'm going to actually try to go a bit faster. I recommend pausing the video to write down the answer while I'm erasing it. Erasing this part, you should be able to pause the video because there is a section here to where you can do that. And yeah, so that's the that is the answer. So now I'm going to try to go a little bit faster because I'm not going to give examples because now I'm just going to do some basic multiplying, not two matrices by each other, but just a number having a matrix be multiplied by that number to then result in another matrix of the same dimensions. Yeah. So this next matrix, since you already know the basics, by multiplying, you just take each number and multiply it by the number. So we're going to say the number 4 times the, and I swear I'm drawing these way too big. Okay, so 4 times 8, let me write it a little more clearer this time. 8, negative 2, 0, 2, 5, 15, 21, negative 2, 0, 4, negative 6, negative 18, and then our last row here is last time I drew 5. So sorry about that. Truly, so sorry about that. The last row is going to be 7, 5, negative 1, 9. Okay, so what you do is you multiply each number by 4. As we already kind of gave you in introduction to matrices, I'm not going to give you an example problem, and let's hope that you can multiply all these numbers by 4 and get the correct answer. I'm going to give you some time to do that. Pause the video within this segment, or the upcoming segment, I guess, and then solve the problem. Okay. Okay, so should have got 4 times 8, negative 2, 0, 2, 5, 15, 21, negative 2, 0, 4, negative 6, 18, 7, 5, negative 1, 9. It should leave you with the 4 by 4 matrix. 32, negative 8, 0, 8, 20, 60, 84, negative 8, 0, 16, negative 24, negative 72. Let me make this in a little bit longer here. 28. It's bad. I'm so bad at drawing 8s on these whiteboards. Something about 8s in this whiteboard. 20. Negative 4. 36. Okay, so that should be your answer. Yeah. Might want to take a second to write that down, so let me give you a second. Okay. Yeah. All right, very good. Now we're going to move on to our third problem. And this time, our third problem is just going to be rather simple. Yeah. Now I'm going to introduce to you guys what an identity matrix is again. There will be no more example problems for either the third or fourth one, because the first one, the whole idea of that first example problem was to give you the basics that you need to be able to do this. Okay? So, now, we want to talk about what an identity matrix is. So, an identity matrix means you take a matrix, so say we take a 2 by 2. Matrix. And the identity means that they're ones all along the diagonals, starting with the first one. Okay, so let me draw this out first. So the identity matrix for 2 by 2 would be 1, 0, 0, 1, because they're ones going across the diagonals, and they're going down to the left, down to the left, never to the right, down to the left, to the left, to the left, and down to the left, and along the diagonals, down to the left, never down to the right, because that's so easy to get confused. Down to the left. I can't repeat myself enough. Down to the left, to the left, to the left. Just down to the left. Going like that. So you start in the upper. Wait. Oh, I'm looking at it the wrong way. It's down. Oh, jeez. It's down to the right. Okay. Alright. Think of it like this. You know how when you write a sentence, you always write left to right. So if I write the sentence, I know this kind of sounds unrelated, but I'm trying to get you to understand this and not make mistakes. If I'm in English class and I write the sentence, I like cupcakes. Not really a sentence, but oh wow, you write left to right. Always go left to right. Okay? And start in the top. Okay. So that is what now you should understand that now. So then for a 2 by 2 matrix, you get that. Now for a 3 by 3 matrix, what do you think we're going to get? What do you all classmates think? We're going to get 1, 0, 0, 0, 1, 0, 0, 0, 1. and that being for a 3 by 3 matrix. So, now try to write the identity matrix for a 5 by 5. This is an easy problem, so easy. Okay? I'm going to give you a moment to do this. Again, pause the video during this moment so that you can do this. Okay, should have got, I'm going to draw a big 1 for this one. Should have got 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. See how the ones are always going across the diagonals? In fact, I'm going to circle this and just take a moment to notice this. I know it kind of sounds silly that it always has to be that way. Kind of a bit ridiculous, but it really does. It really does. It's that important. I cannot stress that enough. Especially important for what we are going to do next. So just take a moment to just kind of reckon this and kind of get this straight in your head so that you never, ever, ever, ever forget it. Okay? Alright, so we have a 3 by 3 or 5 by 5 matrix. Identity. Once followed the diagonals, going down to the right, 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 and down. Okay. Alright. Now we are going to do our final problem of this tutoring video. Isn't that exciting? You guys have really came so far. Since I imagine that a lot of you are just in Algebra 1, because I am in a Algebra 2 as a freshman, which is like I guess mostly like sophomore and juniors, so you're probably in like Algebra 1 or Geometry. And I guess this will let you know what's coming up. And for those of y'all who were supposed to be in the video but didn't show up, let's hope that you watch this and really learn what needed to be taught. Okay, so let me finish erasing these. Alright, now we are going to do something a bit different. Okay. We can use matrices, or matrices, plural, to solve much more complex systems of equations. Okay, so if I have a three-dimensional system, or an XYZ system of equations, where instead of doing substitution or elimination, we can do this instead. Because like a lot of y'all are probably in Algebra 1 and thinking, well Logan, substitution, that's just x and y's. Well, there's also the z-axis. So those of you who don't know, x-axis goes up, y-axis, or no, okay, x-axis goes left to right, y-axis goes down to up, z-axis comes out, and it just goes on and on forever. There's really no way to draw it, because I'm just gonna say I don't know, but it's coming out of the page like perfectly. Like if I were to like take if I took a bow and arrow and shot it right through the center of this graph, that would basically represent the z-axis, assuming it landed perfectly. Okay. So now we are going to take a substitution problem. I'm going to talk about what an augmented matrix is. So, well, first of all, if we have the substitution problem, 2x plus y plus 4z equals I don't know, 13. This is kind of hard to do because this probably won't work because I don't know how to get it so that the numbers are like without getting like completely weird random numbers. So I'm just going to get you guys used to the idea of what is an augmented matrix. Okay, so say we have a 3x3 matrix, but there's a fourth column. Even in a 3x3, there's a fourth column if it is augmented. And what it represents is an x, y, z system of equations. X, y, z system of equations. We call it that because again we had the x-axis left to right, z-axis or y-axis down to up, and z-axis just kind of coming out or coming towards you and just like coming out. So we have the x, y, z, and we'll usually have like a number. So say like for example it would be AB plus y minus DZ. By the way, these extra numbers are just variables. I'm just trying to show you. I'm kind of putting this into a variable form. Let's say that equals F. And then say we have WB minus GY plus HZ equals T. Do this way. And then we have whoops. And then we have 7 or no, what, 7's a number, I don't know, I'm like lost here, or EB plus MY minus OZ equals, that's not really good, OZ equals N. Okay, so but the thing is that these are equations, so now we erase the plus signs. We erase the plus signs. By the way, this is just you don't actually write out the equation inside the box, because you just don't. I was just doing that to show you kind of like what I'm taking it from. Let's just separate these minus gy, that's an actual variable, so let's separate that, plus the WB, and then EB, MY minus OZ, so negative OZ. That would be an example of an augmented matrix, except that this goes down way too far. Yeah. So now, but what you want to do is we actually, our next step would be to erase the variables, because we don't really, why did I write B? That B is supposed to be X. I don't know what I'm doing now. But we erase the variables because now it's just what we are representing the variable for. It's not actually that. So what we actually put is like, we should know X, Y, Z. And as in this row AWE, it's X. I'm going to write it down below just so you can see it better, but in reality they're written up top. I also did write it above, but it's kind of hard to see. Y, negative GM, and negative D, H, negative O, and then FTN as our answers going. So what we would actually want to do is, because you see these all represent numbers, what we would actually want to do is we would, because these would be numbers in an actual scenario, these are just variables representing the numbers, is we would get it so that the whole, so that all of it, or so that at least this part right here, W, E, and M are all zeros. But because then we can then use that to re-plug in, because then we would get our X answer, or it might actually be the Z, I'm not too sure, but we would get, but that doesn't matter. That doesn't matter, because you know what? It's all about getting the answer. So we would get the answer for a variable and then could then replug it in and then do it with a two-way substitution instead of, or a two-variable substitution instead of a one-variable. This is just a method to get it from a three-variable substitution to a two-variable, so that you can actually substitute it or eliminate it, if you prefer to use the elimination method. So I mean, yeah, I'm going to go ahead and give you guys an example of what that would look like. I can't actually set up a problem for this because it just wouldn't like work out, because the numbers for the answer would be like completely like long, never-ending decimals, and I don't even know if I could even who knows? I am a math student, not a math worksheet producer. Yeah. So what this would look like is, let's just pretend. Let's just pretend that we had the augmented matrix. Five, 2, 1. By the way, this is a 3 by 3, which means there's still a fourth column because it's augmented. So 5, 2, 1. And let's say that gives us -4. 0, 2, 3. So that gives us 7. And then 8, -19, 4. And say that gives us 6. Okay. Did that again. I'm gonna do that like every time. Guys, so sorry. But yeah. So what we would want to do is get it so that these right here are all zeros. And who knows what that would look like? I can't actually show it because the numbers that would involve this, because I didn't actually this isn't actually like a problem that you would receive on an exam, because it was written by me, and I'm not like, again, like I mentioned, I don't work in like math worksheet productions. So what we would try to do though is get, by the way, you may want to write this down, so I'm going to give you a second to record this. Pause the video, but then the time that I give you and record it, and then yeah, from then we can just you'll have the problem, and I'll show you what I'm talking about. Okay, so we would get these zeros, the ones that I'm about to circle, the ones below the diagonal. Okay. Everyone below the diagonal, which, as we talked about, and I stressed how this is the diagonal, just like that. You should know that, because I talked about it plenty in this video. We would get these so that, so that these are all zeros. So these numbers all below the diagonal would want to be zeros, but we would have to solve problems to get that. We would have to say, we'd have to take each one at a time and say that may involve taking the first row, but saying the negative of that. So each one of these would be flipped. So 5 would become -5, -2, or 2, -2, 7, -7, 4, 4, and then we would take that and then say add it to row 3, and have that be row 3. So then everything else will stay the same, but then when you add row 3 to that, it would even one of these two variables out to 0, because we would need that. But the thing is that this is not what you'd actually do, because again, in this problem is not realistic, but I'm saying what could happen. So say by doing that would result in this becoming 1, this becoming -2/3, this becoming 4, and again, I'm just giving examples. This would not actually happen. This is not actual math here, but the thing is that I'm saying what it would look like to solve an actual problem like this, where you would actually do stuff like that. You'd have to like figure it out. So if you had one variable as 6, then you may want to multiply or subtract 6 from all of row 3, and then have that then be row 3. So, or row 2 for this one, if it's not already at 0, to make it so that those are all zeros. And then when we get that, when we get our actual solution, so say we then now take this, and we now do something weird to it. Say we do 2r2 plus r3 gives us r3, and then that changes it to, I don't know, but this would actually change it to 0. This would have to change it, although it obviously wouldn't, but an example of what one would be, changing it to 0, 0, say this changes to 14, and this changes to negative 35 elevenths. This is possible, by the way. You can get very weird numbers, so I'm just trying to show you what could actually happen. And then we would then take this and say, okay, one of the variables, say variable, I don't know, z equals 14, and then we could then plug it in and say, okay, or it would be 14z equals negative 35 elevenths. Two 2y plus 3z equals 7, and then 5x plus 2y plus 7z equals negative 4. We could then solve for z. Who knows what it would be in this case, because it's not an actual legit problem that we're doing here, but rather just an example of what it would be like to solve a problem. Because, yeah, I'm going to explain to you why we're doing that. If you're paying attention, you should know. So, I mean, we could then solve for z, and then say we solve for that and say z equals 4, and we could then say, okay, solve for y. Say that gets us to y equals 6, and then plug in and say that gets us to that x equals 3. And then we would write our solution as 3, 6, just like in an ordered pair, how you always write the solution as xy, but when we add the z, guess what it becomes? X, Y, Z. Okay. My phone was going off there, so sorry about that. But yeah, that would be an example of what the answer, or of what an answer could be, and how it would be like to work out an augmented matrix problem using XYZ systems of equations with all variables XYZ. But yeah, thank you guys for being in this video, or for watching the video, I should say. And go ahead and I guess like, subscribe, whatever you guys, you viewers do. And we will see you on the next episode. Yeah. Okay, hope you guys learned some math. Especially, yeah, if you've never seen stuff like this before. I'm gonna have to pick that up. I'm also gonna have to wash my hands, because my hands are just like a disaster, because I've been erasing the whiteboard with my palm of my hand, which I wish I had like a Kleenex or a tissue or something to be able to do that, but I don't exactly have that on me. do have limited resources in the video. And again, a disclaimer on how there were not people who were actually in the video, because there were supposed to be people who actually showed up in this video, but unfortunately they didn't show up. So yeah, anyways, thank you for watching this video, and come back and enjoy the next video that I post. Goodbye. Sorry, screen froze there for a second.